Welcome to my channel. In this video, I am going to discuss images formed by a concave mirror. In my previous video, I have discussed how reflected light comes from a concave mirror, discussing through 4 different rules. Now, let us see first understand what is an image. The intersection point of 2 reflected lights by a mirror is called image of the object. For example, if I have a concave mirror like this, and if a light ray is incident and reflected back, again a light ray is incident, reflected back. Now these two are getting focused and intersecting at this point. So this is the image. Now if I have 2 light rays which are not intersecting but which appear to diverge from this point, then image is formed at this point. So if the reflected light is like this, then the image is said to be virtual, and here the image is said to be real. In both the cases, the reflected light should intersect at one point. Now today's discussion, we will see what are the positions of these images in a concave mirror when an object is placed. So the position of the object decides the position of the image and also the nature of the image. The nature of the image means what? The size of the image and whether it is real or virtual. So the characteristics we will discuss. Now to understand that, I will be discussing in different positions. Now let us see. Suppose the image object position is at infinity, very far off, and then I will move on to some position which is beyond, C. This is C, this is F, this is P. P is pole, F is focus, C is center of curvature, and this is somewhere very far from C, so beyond C. So this is number 1 position, number 2, and then at C is number 3, and between C and F is number 4, and at F is number 5, and between F and P is number 6. So these are the 6 positions of the object, and we are going to see one after the other how the image is formed and where exactly the image is formed by understanding the reflection of the light intersection point. So it is actually the object position is moving towards from infinity towards the pole. Then we will see how the images are formed and we will understand. So first we will see the first case when the object is at infinity. Now let us consider a concave mirror, and this is the coated portion, and this is your P, this is pole P which is at the center, and now let us see. Now infinity means from a far off distance. So if I have a light ray incident, so the object is at infinity. So I have an object which is AB from far off. So this is infinity, and if a light ray, obviously from infinity the light ray is passing and incident at D. So AD is the incident light, and whenever a light is incident, what will happen? The light will get reflected and it is passing through F. Now this is a line which is passing through C, which becomes the normal. So this becomes angle of incidence, this becomes angle of reflection. So this is our one reflected light, which we have discussed in our rules that in my last video. Now, if I consider the light coming from far off another light ray, and that also once again gets reflected and passes through F. So this is the point E. This is the incident light. So now these two are the reflected lights. This is one reflected light and this is another reflected light. So these two are incident at F. So this is your intersection point, and that's a point sized image. Therefore, it is the real image inverted, point sized, that means highly diminished. And where is the image formed? At F. So the image is formed at F and it is real and inverted and it is point sized. So these are the characteristics which decide the nature of the image formed. Then we will go to number 2. When the image is at, when the object is at a position beyond C. So let us consider a concave mirror. Now I have this P, and somewhere very large distance beyond C we have the object AB. So I have the light incident from the object which passes through F when it after reflection. So this is the incident light AD and reflects along DG passing through F. This is one light. Then we can consider another light. Now let's say this is C, center of curvature. So another light passing through C, and this any light ray passing through the center of curvature will normally incident on the concave mirror. Therefore, it will be reflected back. So it is incident and it gets reflected back. Now this is the point of intersection where the two reflected lights, what are the two reflected lights? One coming from D, from the mirror it is reflecting along passing through F, and another one which is reflecting from the point E passing through this point coming back again through C. So this is the point. Now this is our image position. So image is, I will write B dash A dash. So AB is the object beyond C and A dash B dash is, where is the image now? Image is formed at between C and F. It is formed in between C and F and it is real and inverted, and what is the size? Obviously the size is smaller than the object. So smaller than the object, which means I can write diminished. it is not highly, so it is diminished. So you can have some small size there. Moving on to the next position. So where will we move? Now we went to infinity, infinity to beyond C we came. Now we will see the object at C. So we are moving, I showed you. So let us see, I have a concave mirror and this is P. So now I will join this one, this is P, and the surface we can write in all the cases Mn. Concave mirror surface we can write Mn. So this is, now if I place, this is F, this is C, now object is at center. Then from the object a light ray is incident at D and passes through F, and another light which is passing through F is incident at E on the mirror, and whenever a light ray from an object comes through F, it reflects parallel to the principal axis. So this will be like this. So now this is one reflected light and from D, and this is one reflected light from E. So these two are now intersecting at this point. So this is the image position. So this will be now B dash, A dash. So what are the positions? So at C, image is formed at C, then size of the image is same as, that is A dash, B dash is same as AB. So size is same, and then real and inverted, real and inverted, real and inverted. Now where do we go? We go to between F and C. So the image position is between F and C. Now this is the concave mirror. Now we are taking the object in between. So this is P, this is P, this is Mn, surface of the mirror, concave mirror, and I am now considering the object between, this is F and this is, let's say, F, and in between F and C, so this will be the object position AB, and light is incident and will be reflected, one light will be reflected along focus F. At the point D it is incident and it gets reflected along, passing through focus. And if I consider another light incident, and will be intersecting like this. Now this is E, so this is C, center. So what will happen? This is a line AE which will be reflected back, because it is a line passing through center, which will be normally incident, so it reflects back in the same direction. So these two reflected rays will intersect at this point. So what is happening? You have a image position at this point, and this is A dash, B dash. So what are the two rays which are intersecting? One which is reflected from D, another which is reflected from E. Now what do we understand? The image is beyond C, and the image is very far from C. So here it is formed when the object is between F and C. This is the object position. And then the image is real and inverted. And when we look at the size, it is enlarged, or I can say magnified. That means it is larger than the, you can see that the size is bigger here, it is more. Okay. Then we will go to the next position. So where will we go? So from here we have moved like this and we came here. Now at F, when the object is at the focus. So when the object is placed at focus of the concave mirror. So we will see how we can draw this diagram. These are called Raydiagrams. So now I have P here and I have F. So this is F. So the object is at F itself. So this is AB is the object, and this is the light which is incident and which gets reflected. So this is all same as we have discussed in all these cases. So AD, so which is incident, from D it gets reflected and passes through the focus. Then when I have MN is the surface. So when I have another light which is passing through C, and this is AE, and it is incident and it gets reflected back because it is passing through C, therefore light is incident normally. And these two will never touch. So this is infinity. So these two run parallel to each other. So the image is formed at infinity, which is highly enlarged. So the image positions are at infinity, the image forms at infinity, then it is real and inverted, and then highly enlarged. It is very far off and it will be very large. So when it is from far off from C itself, it is big. So when it is very far, almost like infinity, it is much bigger, hence it is highly enlarged. So these are the cases. Then the last case. Now let us look at the last case. Last case is when the object is between, now we moved up to focus, so beyond focus, so that is between F and P. So now let us see. I have the mirror, I have the concave mirror. Now when I have the concave mirror and I am placing my object, so this is P, when I am placing the object between, now let us say this is F, so between F and P, so when it is placed, then I have my object here. Okay. So when a light is incident, AD, it passes through, reflects and passes through focus, and let us say I have another light AE incident which is passing through C. So this is C, passing through C, obviously it gets incident and it gets reflected back. Now when you see, these two will appear to come from this point, which means when it is produced backwards, they are meeting at this point. That means they appear to diverge. They appear to diverge from a point. So obviously this is a virtual image, and this is the only case you will have a virtual image formed, and this is your virtual image, and it is erect, upright, it is not a inverted image. So it is upright. So what are the positions of the image? Behind the mirror, and it is virtual and erect, and it is magnified or enlarged, bigger than the object. So this is your object and this is your image. So bigger than the object. Now we have seen. So what did we start with? We have seen all these positions: infinity, beyond C, at C, between C and F, at F, and then between F and P. Now we have seen that image positions are moving through F, and then between C and F, and at C, and beyond C, and at infinity, and then it is behind the mirror. So to conclude, what we can see is, look at this. If I summarize the images formed by a concave mirror with respect to these, so this is the position of the object, and this is the position of the object, position of the image formed, size of the image, and nature of the image. Now as you can see, this is the only case where you have virtual and erect image, and in all other cases the image formed is real and inverted. So in a concave mirror, it gives, in most of the positions, it gives only real and inverted, and only in one particular case, when the object is between pole and focus, the image is virtual and erect, upright, and it forms behind the mirror. So the image is forming and moving from behind the mirror to like this, in this direction. So the image is moving in this direction, behind the mirror, focus, and between center and focus, like this, it is moving in this particular direction from up to infinity. So this table summarizes, and that gives you the idea of how images are formed by a concave mirror. Now in my next video, I will discuss the images formed by a convex mirror. Until then, keep watching, keep learning. Thank you.